my name is Tripp, in case you forgot in the past couple of weeks. I'll be talking about like supercharging and turbocharging for internal combustion engines, which is just a form of power boosting for the engines. Alright, so I'm just going to give a brief overview of a standard car cylinder, which we should all be fairly familiar with from thermo when we learned about the four-stroke cycles. So you got your piston, crankshaft, your piston inside the combustion chamber. Your intake valve, which will be basically what we're going to be talking about today, is just how the forced induction will actually increase the air density going into the intake and increasing the amount of fuel that can be burned. You got your two intake valves, intake exhaust valve, your spark plug. So once the piston goes up through the compression stage, the spark plug will ignite the ignition, the fuel source, throwing the piston back down for the actual power stroke, and then the other lock stroke again will go out through the exhaust valve. All right, so again, we're talking about power boosting for car engines, and we're going to be talking specifically about forced induction. So now, the amount of power that an engine can actually produce is limited by how much fuel each cylinder can burn. Now, how much fuel a cylinder can burn is limited by how much air can actually, or how much oxygen you have in each cylinder. Now, for a naturally aspirated engine, so that's just when the engine just takes atmospheric air pressure into inducting into these cylinders. And oxygen only makes up about 23% by weight of atmospheric air, so you're really limited to how much fuel you can burn, just because you only have a very small amount of oxygen. So now, this forced induction will actually take atmospheric air, compress it, so the turbo and supercharger both compress the air density, so you're increasing the amount of air, like how much oxygen going in per mass per unit volume. So you can actually burn more fuel, so the temperature and the pressures inside the cylinder will increase, making the piston move faster and harder, and creating more power. All right, so first we're just talking about superchargers. Now, superchargers were really like the first power booster by forced induction introduced to engines. Now, superchargers are a power boost using the unit displaced volume, so just really you're increasing the amount of mass of the oxygen per unit volume. Now, the key characteristic of a supercharger is that it's mechanically driven. So that means the engine itself is directly driving the supercharger. So it's kind of hard to see with this picture, but since the crankshaft is moving here, which is moving this wheel, and there's a belt connected here. So there's a belt connected here to the top of the supercharger, which is actually up here. So as the crankshaft is spinning, it's actually moving these screws inside the supercharger, bringing in air, compressing it, and then inducting it in each of the cylinders here. Now, there are two types of superchargers. There's a positive displacement, which means that the supercharger is inducting a constant volume of air at high speeds, at all speeds. And then there's dynamic, which really just means it accelerates the air to very high speeds and then just converting that velocity into higher pressures. Now, some of the uses of superchargers. They're not as popular as turbochargers are, just because they're much larger and a little bit less efficient than turbochargers. But one of the main benefits of a supercharger is that it has an immediate power boost. So like we said in the previous slide, that since it's being driven by the engine itself, so if the engine is moving, the supercharger is working. So you don't have to wait for anything to build up. It's always working as long as the engine is spinning. So that also being said, you can get a good power boost at low RPMs. You don't have to rev up the engine, get higher RPMs, high temperature and pressures to actually move the supercharger. And also, superchargers are really helpful for piston aircraft engines. So like you can see here in the Rolls-Royce Merlin engine, which were used in the British Spitfires during World War II, because when you're flying at high altitudes, your air density is much lower because it's compressible. So your oxygen you have even less oxygen than when you do at sea levels. So supercharger can actually increase the density of the air to bring it back to like sea level conditions, so the engine can work at normal efficiency and normal operating conditions. All right, so now, again, like I said, since it's mechanically driven, that's probably the biggest drawback of the supercharger is how it's less efficient. So like from this pretty simple schematic here, you can see the supercharger is directly connected to the engine. So all the power that the engine's producing can't go into the drivetrain. Some of it's got to go into driving the actual supercharger. So you're losing power there. However, and also, the supercharger can really increase the temperature of the engine. And at extreme temperatures, you can cause like premature detonation of the fuel source, which can really damage the engine. And as well as, the same for turbochargers and superchargers, is that the increased pressure of the exposure of increased pressure to the internals really just causes damage and further deterioration. All right, so now we're going to talk about turbochargers. They were introduced later than superchargers, and technically they are just a variation of superchargers because they're both forms of forced induction power boosting. But the main difference between a turbocharger and supercharger is that the turbocharger is not actually mechanically driven. So you're not relying directly from the engine to drive it. So from this schematic here, it's actually being driven by the exhaust. So normally the exhaust is just expelled from the system. So it's like, well, after you burn it, it goes through the exhaust stroke, gets expelled through the exhaust valve. You don't really, it just kind of goes out through your tailpipe. Whereas a turbocharger takes advantage of that so-called free energy. So it can spin it up and it'll spin the turbine wheel, which will spin the compressor pin, setting it in there, compressing it, and then sending it into each of the cylinders. Now, turbochargers are much more popular these days. They're really used on large engines such as like trains, trucks, and large construction engines, as you can see from this giant cat engine over here. So he's using 4 turbochargers at the very top there. They're also almost exclusively used on diesel engines because diesel engines use a lean fuel. So that means your fuel to air mixture is pretty low. So the diesel engines don't really use all the oxygen in the air. So you can use a turbocharger to increase the amount of oxygen going into the engine so you can burn more fuel, get more torque out of it. Also, since turbochargers are a little much smaller, more efficient than superchargers, you can actually implement 2 of them, 4 of them, like multiple. So like it's really popular on high performance sports cars, you can see here, and as well as the Sport here, that you can implement the turbocharger, the twin turbo, so you can get even more power out of it. And probably the most popular use of it today is on smaller engines. So you can put turbochargers on smaller engines and actually get the same amount of power as a larger engine. I'll talk a little bit more about it later, but basically, like, well, you can take like a V6 engine, substitute with a 4-cylinder inline engine, and put a turbocharger on there. It's more efficient, but you're also getting the same amount of power as the V6 engine, which is really neat. Now, the biggest drawback to the turbocharger is, like I said, since it's being driven by the exhaust, there's a little bit of a lag. It takes time for the engine to build up a sufficient temperature and pressures of the exhaust to actually drive the turbocharger. So like you won't see it immediately as like you do with a supercharger, because as long as the crankshaft is spinning, the supercharger is spinning. So it takes a minute to actually see the benefits of the turbocharger. And also there's a boost threshold. So there's only a certain range in which the turbocharger can work. So it takes some time to get there. And so there's not as wide of an operating range as a supercharger has. And then thirdly, there's the power surge. So again, once it takes a time to get to that boost threshold, but when you do, there's almost an immediate power, like you immediately feel that power boost. So you can compromise like tire traction and vehicle stability sometimes because you can be just driving along, and as soon as you get that boost threshold, like you're automatically getting that extra power out of nowhere. And lastly, turbochargers can get really hot, so you have to they will have to actually tap into the oil reservoirs of the engine, so that can just mean that the oil is being used faster, so it requires more plumbing, more maintenance, because you have to replace it sooner. All right, now lastly, to summarize the differences and benefits of turbocharging and supercharging. So like I said, supercharging, again, the main benefit, they're both completing the same task, but just different ways. They're doing the same function, just different methods of doing so. And like I said, turbochargers are mechanically driven, so you see that immediate boost of power. So there's a lot of power as soon as you start the engine. So like you can see in this animation here, the black Charger, when you start off, he's much faster off the line because he's using a giant supercharger. So as soon as that engine is running, he's getting that immediate power boost. So he's getting massive amounts of torque to his rear tires. That's what makes it pop up, and he looks much faster off the line. But turbochargers are much more efficient. They do a little bit of lag. That's why this super right here, it looks a little slow and laggy off the start line, just because he doesn't have the same power boost as this Charger does. But turbochargers are probably the one most used form of power boosting, and you really see them a lot today. Like I said, like if you look at cars that have been made in the past couple of years, like standard cars, like you'll see like cars manufacturers are replacing like V8 engines with 6 cylinders with a turbocharger because you get more fuel efficient V6 in the V8, but you have the same amount of power as a V8 because you put the turbocharger on there. And like my car, I have a 4-cylinder engine with a turbocharger on there because while it might need like the power of a V6 to adequately drive the car, you can use a more fuel efficient 4-cylinder engine, put a turbocharger on it, and still have the same amount of power. So you have the same amount of power as a larger engine, but you have better fuel economy. So it's really popular with car manufacturers nowadays. And I think that's all I have. Any questions? Yes, James.
Do you know how long turbochargers have been in use?
The first one was invented in like the 1880s, actually.
I mean, like in automobiles.
So I think in the past like 10 years or so, they're starting to use more often, like in like everyday cars, but they've been like using ever since like drag racing and high performance cars, like
okay.
Building high performance cars and engines that you need.
So, and my follow-up question is, do you know anything about catalytic converters? Doesn't that do like something similar as far as using the exhaust for power?
So the catalytic converter, it's not so much a power boosting, and it's actually really a headache. What I read about is like to actually use. Nowadays you use fuel injection, so you're mixing the fuel and the air like as soon as it's going into the injection. So the catalytic converter actually will take the air and fuel and mix it before going into like the runner's and intake valve. So they're really not, they're outdated now, really. That's like, so they're just more different types of fuel injection where you can mix the air and fuel without the catalytic converter. That's what it really does.
Okay.
Is it just runs the engine like naturally aspirated. It's not a power boosting, it just really just mixes the fuel and air so they can be ignited inside the cylinders.
Okay.
Yes, sir.
So my mom drives, I want to say it's like a 2.0 T. Does that mean it's a 2-cylinder turbo engine? Can you have
2.0, that's probably the volume displacement. That's not so much like the twin turbo. I think that is a turbocharged, but usually like if you see like a 5.6 or like it has like a number in front of the engine, that's usually the volume displacement. So that's just like how much the difference in volumes of the piston cylinders.
Okay. All right.
Yes, Kayla.
This might be kind of a silly question, but you mentioned for the turbocharger that it uses the exhaust gas.
Right.
What is actually exhausted through the tailpipe in a turbocharger car, for example? Like, is it just air and gas that's not used to go into the turbocharger that's still exhausted out?
So you have your exhaust here. So after the exhaust out, it goes up through here, the exhaust stroke, and it spins a turbine, but that exhaust is just still going through the turbine. It's just taking advantage. It's basically, if you have your exhaust like runner, like if you have a whole system of just exhaust, basically you're putting the turbocharger right in the middle of it, and the exhaust fumes will spin the turbine before going out to the car. So like you're still like you can barely see it here. Like the exhaust is still going out, but it's spinning the turbine first.
So it's the same environmental impact and everything.
Yes, you're just getting more power, and you can like get more efficient, like a more like fuel efficient car. Like you're still going to be burning that fuel, and it's still being exhausted into the air. So it's not environmentally friendly because it's the same exhaust. It's just spinning the turbine before it leaves the car. Any other questions?
Do you know kind of like percent-wise how much increase in air a turbocharger does as opposed to just a standard engine?
I don't know the exact. I think it also depends like how much varies on turbocharger, how much you can actually get, like how high density you can get from the air.
Mm-hmm.
So like I think different variation of turbochargers, you can like different densities. So it all depends on how high you can get, how high increase you can get the air density.
Got it.
All right, any other questions?